Hi, this is your teacher Barbara Rademacher, and we're going to solve some application problems that necessitate your solving a quadratic equation. Okay, here's problem number 11 in your homework. The area of this rectangle is 21 square units. They mean square inches, square feet, something like that. Find the length, the horizontal side, that is this side, and the width, the vertical side, of the rectangle. So we're going to do that. First, we're going to write an equation using the formula and the given information. So remember, please, that the area of a rectangle equals length times width. So the formula will be A equals parentheses x plus 2 times x minus 2. Well, 21 is the area, so we're going to say 21 equals x plus 2 times x minus 2. Let's see if that's right. It says do not multiply. Okay, I won't. Okay, now it says solve the equation, giving only the solutions that make sense in the problem. All right, and so we have to find x first. So let's FOIL x plus 2 times x minus 2. This will give us x squared minus 2x plus 2x minus 4. So the middle terms cancel out, 0 out, and we're left with 21 equals x squared minus 4. Now, as always, when you solve a quadratic equation, you move everything over to one side and set it equal to 0. This is called the zero principle. So we're going to have 0 equals x squared minus 25. So 0 equals parentheses x plus 5 times x minus 5. We set each factor equal to 0, x plus 5 equals 0, and x minus 5 equals 0. Solve each little equation, you get x equals negative 5 and x equals 5. You get two answers for x, but what makes sense? Well, if we were to let x equal negative 5, that would be a width of negative 7 and a length of negative 3. Have you ever heard of negative length and width? I don't think so. So x equals negative 5 makes no sense in the context of this problem. We're going to have to go with x equals 5. Very good. Okay. Now, we're going to have to find the length and find the width. Put a 5 in for x. For the length, you'll get x plus 2, which is 5 plus 2, which is 7. And for the width, you'll get 5 minus 2, which is 3. There we go. We did it. Let's move on. Remember, you can replay any of these problems. The length of a rectangular garden is 2 meters greater than the width. The area is 80 square meters. Find the dimensions of the garden. It's another rectangle problem. All right, let's read it again. The length of a rectangular garden is 2 meters greater than the width. So if we draw a picture, This is the length and this is the width. And we're told that the length is, remember is equals, the length is 2 meters greater than the width. And we're told that the area is 80 square meters. So we know that area equals length times width. So 80 equals W plus 2 times W. So let's multiply W by that W and that 2. We'll get 80 equals W squared plus 2W. Then I subtract 80 from both sides so that I can follow the zero principle, because I need to have a 0 on one side. I need to have my quadratic set equal to 0. So I'll have W squared plus 2W minus 80. And I have to find the factors of negative 80 that will add up to positive 2W. Now what could that be? Well, we can always pull out our graphing calculator, or we could just use our common sense. You know that 80 equals 8 times 10. Well, negative 80 equals negative 8 times positive 10. And if you add negative 8 to positive 10, here we go, negative 8 plus 10, this will give us positive 2, which is our B number. So I'm going to say that this will factor into, let's move up here so I have room, 0 equals W squared plus 2W minus 80. That will factor using the simplified grouping method of W, and then the two factors I'm going to go with are negative 8 and positive 10, so minus 8 plus 10. Now set each factor equal to 0. W minus 8 equals 0. W plus 10 equals 0. So W equals 8 or W equals negative 10, but how could the width be negative? How could the length be negative? You can't have negative measurement in the real world. Try going to Lowe's and saying you want negative 10 feet of wire or negative 10 meters. They'll just say no. So we're going to skip W equals negative 10 and we're going to let W equal 8. So the width of the garden is 8. Now remember that the length is 2 more than the width, 2 more meters than the width. So if the width is 8, the length is going to be 8 plus 2, which is 10. There, we've got it. What we have is a rectangle that's 8 meters wide and 10 meters long. Okay, now we're on problem 13 in your homework. The base of a triangle is 7 centimeters greater than the height, and the area is 60 centimeters. We're talking about a triangle. The formula for the area of a triangle is A equals 1/2 base times height. Oh, A equals 1/2 base times height. Now we're told that the base of the triangle is 7 centimeters greater than the height. So just to draw any triangle, because the problem doesn't say what kind, that's the height, and this is the base, and we're told that the base is 7 centimeters greater than the height. So now I'll put this all back in the formula. A equals 1/2 times the base, times the base, which is h plus 7, times the height. That's not neat. Let me write it again. A equals 1/2 times the base, which is h plus 7, times the height, which is h. That's much better. Okay, the first thing I'm going to do, now if I were to turn 1/2 into 0.5, this problem would become suddenly harder. Instead, if I leave this 1/2, I can multiply both sides of the equation by 2 in order to cancel out the 1/2. See, the 2's will cancel here, leaving me with 2a. Oops, now what is the area? The area is 60, so we know the area, and I'll change that in just a minute. Now I'm going to multiply h times h and h times 7. Okay, before I do anything else, a is 60. So 2 times 60 equals h squared plus 7h. That's 120 equals h squared plus 7h. Then subtract 120 from both sides so that you can set your quadratic equation equal to 0. So you'll have 0 equals h squared plus 7h minus 120. And now we need to factor that. For this, I'm going to bring on my friend Wabbit Moo. All right. So notice here that my A is 1 and my B is -1, my C is -120. So I'm going to say 1 times -120 divided by x, and then in y2 I'll say x plus -120 divided by x. Second graph. And I'm looking for my B number 7. There it is. There's 7 right there. The two numbers accompanying 7 are -8 and +15. Now, since our A is 1, we get to use the simplified graphing procedure, which I really like. Not graphing, grouping. The simplified grouping procedure, which is this. I've got a -8, so that's -8, and I have a +15, so that's +15. And now I have factored h squared plus 7h minus 120. Now, I have to solve this equation. I can't just factor it. So I set h minus 8 equal to 0, and h plus 15 equal to 0. When I solve each of these little equations, I'll have h equals 8 and h equals -15. Again, you can't have a negative height. That would be going into the ground. So we're going to get rid of that negative when we're talking about length, width, height, whatever, and go with h equals 8. So the height of the triangle is going to be 8. The base of the triangle is, okay, I'm going to move the calculator now. The base of the triangle is going to be 7 centimeters greater than the height. If the height is 8, then the base is going to be 8 plus 7, which is 15. And check my answer. Well done, Barb. Okay, I'll talk to you later.